Hi, calculus student. This video is 5.4 part 1, chapter 5.4 part 1, is to look at some basic integration formula to help us to do either definite or indefinite integral and also a net change. We look at something called net change theorem, which is the direct result of the fundamental theorem of calculus part 2. We'll use it to solve some work problem. So, the first integration formula that I want to talk about is actually nothing new. So if you are to do an integration either definite or indefinite, you want to make sure that you are if you're doing an x to the p terms, if you are the integrand has terms of x to the p, then you can just use the power rule, right? So remember, if it is if I have x to the n or x to the p, if I want to do it dx, then the after integration is x to the p plus 1 over p plus 1 or 1 over p plus 1. So this is valid for either radical or integers p. But if you have something that is a group of expression, like the first example, 2x minus 5 squared, there's no product rule per se. So what you do is you actually have to FOIL them out so that they have individual terms. There's no quotient or product rule. The second and the third one are kind of a direct result of an integral. So you know that if I have originally, if I do the integration, do the derivative y, if it's y equal to 2x, and if I do y prime, it is 2 times, because of chain rule, 2 times e to the 2x, because 2x is kind of the inside function, e of x is the outside functions, right? So if I do integral of e to the 2x, it makes sense that I would have to divide the 2, because when I do the derivative, I multiply the 2. So this would be e of 2x over 2 plus c. So in general, we'll have this rule, e to the kx dx is e to the kx over k. And the same for sine and cosine. If I do a differentiation of sine kx, like 3x or something, I have to multiply the k outside for chain rule. So if I do integration of sine kx, I will just divide it back, right? So these are the simple kind of as a result of a simple chain rule. So let's do some example on how to apply them. Now, in this set of example, I have some definite integral. That means we're finding area under the curve. We have some indefinite integral. So I just want you to see how they're the same and different. So in all cases, first of all, you look at what you can do in terms of the rules that you're going to apply. So 2x minus 5 squared, this is not a power rule, simple power rule. So I should actually FOIL them out. 2x minus 5 squared is 4x squared minus 2 times of 2 times negative 5. So it'll be 20, right? 20x plus 25. So I'll FOIL it so that I have individual terms, because my power rule is on individual terms. So this is a definite integral. So we would do 4x squared minus 20x plus 25 dx, and actually do the integral first, which is 4x to the cube over 3 minus 20x. X will become x squared over 2. So I would have 10x squared plus 25 will become 25x. And I'm going to evaluate from 1 to 2, or I plug in 2 minus 1. So that would equal to 4 over 3 8 minus 10 times 2 squared is 4 plus 25 times 2. So this is the first set, f of b, minus f of a. I'm going to plug in 1. So every time I plug in 1, it's just 1 minus 10 plus 25. So you evaluate twice, and then you subtract them. So this would be 32 over 3 plus, this is 50, but plus 10, right? You can do it by hand, like this. Of course, you can use a calculator to help you. It'll be 4 over 3 plus 15. And then after you simplify everything, it will be, this is plus 30, so 62 over 3, minus, this is 45, 49 over 3. And what would I have? 62 minus 49, 13 over 3. I'm going to show you something here also. If you want to check answer, I recommend you to go through this process so you are proficient at doing this fraction and also calculation by hand. But you can also check answer by going to decimal. Okay, so what happens is if you this is the decimal and you get the keypad and you see that there's function under. Normally you would do track and stat or whatever, but under or what is this? Oh, the histogram and all those. Under miscellaneous, there is a integral. So you can also use this to do, what was our integral? Our integral is 1 to 2, right? So it's a definite integral, only for definite integral. 1 to 2, and it's 2x minus 5 square dx. Okay, so this is the answer. 13 over 3, so you can check answer like that. Okay, use decimal. The graphing calculator has similar things called FNINT. Maybe while we're on this, maybe I'll just show you. Graphing calculator, like here, if you turn it on, and then you say math, this is math. Here, FNINT. You can enter your A and B like 1. Oh, I have to use this keyboard. 2, and then I have to say, oh no, I have to use this. 2x minus 5, x is this, minus 5, close, and then square, and then you say dx, you actually have to say dx, then enter. Oopsie. What was wrong? Oh, one of the parentheses is wrong. I don't know. I think one of these parentheses they don't like. But anyway, that's how you can do them. If they still don't like the parentheses. But you can, if you have a calculator, you can do it that way. Okay, so let's continue with this. I'll show you in class. Okay, so this is a indefinite integral, so you do not need to plug in anything. You just need to do plus c. Okay, it's a family of antiderivative. E of 2x, so it is 2 is k, so you would say e of 2x over 2 plus x over 2. That means my k is 1/2, so I would say 1/2 e of x over 2 still, but divided by 1 over 2. So these two cancel, so it'll be plus c. So it'll be e of 2x over 2 plus e of x over 2 plus c. Okay, the third is also a indefinite integral, just antiderivative. So we, but there is not one term by term, so we would have to rewrite it. X over square root x is x 1/2, right? X squared minus x squared over square root x is x 3 over 2, because that would be x to the 2 minus x to the 1/2, and then dx. And then we just apply the power rule. X 1/2 would be plus 1 is 3 over 2. So I say 2 over 3 times 3 over 2 minus x to the 3 over 2 plus 1 is 5 over 2. So I say 2 over 5 x to the 5 over 2, and then plus c, and that's the answer. Now the next one is a indefinite integral. It's a definite integral, so you have to plug in 0 and 4. So let's do the antiderivative first. So because it's sine x, so it's negative cosine 2x over 2, right? Minus cosine, no, cosine's antiderivative is sine 2x, and then because it's a 2 inside, add over 2. And then I have to plug in pi to 0. I believe after I do everything is equal to 0, but we can rerun this in the class. Okay. So that's how you do that. some basic integral and indefinite integral. The second part is net change theorem. So this is the formula. So the formula for this fundamental theorem of calculus say that if I want to do AB, I would f of x, I would do the antiderivative of a of this of b minus antiderivative of a. So going backward, we would say if I am okay, so this should be dx here. If I am doing if someone give me an array and I want to find fb minus f of a, that this is the net change. So the net change of a function from a to b, from a to b. Okay, so this is a function of b minus function of a. So I can actually use the ray function and then do a definite do a definite integral. So the net change theorem say if you want to do fb minus f of a, which is net change from time or x equal to a to b, then you do a definite integral that can help you. So basic, and then the other use of it is if you plus f of a on this side, so f of b can also be done by equal to f of a plus the net change. So this, you can think of this as the initial value, and this is the net change. So what is the final answer for b is the initial plus the net change. And notice that you never need to find what f of x is, and you can actually find net change. So all in all, the net change idea is how to find net change. Net change is the is a definite integral of the ray. So if you want to find f of b, f of a, f of b minus f of a, you would say, well, I want to find it. I don't know how to do it. So you would do the rate of f, which is f prime of x dx, and then do it from a to b, then equal. Okay, so that's the main idea. And we'll do the first example, which is to find the total displacement or net displacement of a particle from time from 0 to 3 interval. So we don't know from 3 and then stop at 3, where does the particle move? But we have the ray, okay, because f prime of t is v of t. So this is the ray function. If I want to find the change of displacement, I have the ray function. That's really good. So that would directly equal to 0, 3 v of t dt. Right. So that is equal to from 0 to 3, 3t minus 5 dt. So that is equal to 3t squared over 2 minus 5t from 0 to 3. 0 we don't have to do. So it'll be 3 over 2 times 9 minus 15. So that's 27 over 2 minus 30 over 2. So actually it's negative 3 over 2. It displays backward from 0 in the beginning, or it moved backwards negative 3 over 2. So that's how you do displacement. How about total distance travel? Total distance travel do not take the negative position into consideration. So you need to find out when it changed direction. So let's say v of t. When does it change direction? That is when it is 0, right? So when it is 0, that is 3t minus 5 equal to 0. 3t is equal to 5. T is equal to 5 over 3. So 3t equal to 5 over 3 is going to change direction. So we can check from 5 over 3 to 0. Let's say if I plug in 1, it's going to be traveling negative. Well, actually in the beginning, 0 is negative, and then it changed positive. So the way to do this would be you would have to do a 0, 5 over 3, absolute value of v of t, plus 5 over 3 to 3, absolute value of v of t. So this is positive, so we don't have to do anything. It's just v of t dt. But this one is negative, so if we take out the absolute value, become negative of v of t dt. So you're doing two of them. Let's